question 2C from our energy level questions. And we're using that energy level diagram from hydrogen that we've looked at already, which is just this one here. And it's saying of each of those three transitions, and it is just those three transitions, would any of them produce photons that would have enough energy to cause electrons to be emitted, so do some kind of photoelectric effect type stuff. So we've got our threshold frequency. Now there's lots of ways of attempting this question, but potentially the most logical one is to go, well, if that's the threshold frequency, what is threshold energy? So E is equal to HF, 6.63 times by 10 to minus 34 is our Planck's constant. Our frequency, 5.1 times 10 to the 14 hertz. So the threshold energy is 3.38 times by 10 to the minus 19 joules. Because our energy level diagram is all in electron volts, well, we can convert everything in electron volts into joules, or this into electron volts. That seems the easiest thing to do. So 3.38 times by 10 to the minus 19 joules. Let's divide that by the charge on the electron to give us 2.1 electron volts. So if any of these photons have an energy bigger than 2.1 electron volts, then we'll be able to do some of this photoelectric effect bits. So let's jump back to our spectrum. So the magic number is 2.1 eV. Transition A, well, that's less than 1, so that isn't going to work. B, I've got to do a bit more maths here, but that's going to be 1.9, so again, that's not quite enough. C, however, that's much, much bigger than 2.1. So that will be able to produce photoelectrons. So what I'll need to do back here in my question is to sit there and say, so C will work as the change in energy is bigger than 2.1 electron volts. As I said, there's other ways you could have done it. You could have worked out the frequencies of all the photons that are emitted to compare it to 5.1, however you want to do it, but just making it really clear that C is the only one that will work.